Hi and welcome to Working with the DOM. So yes, now we will interact with the document object model. But before we do, we should clarify some terminology. Remember, the DOM structure you've already seen in the previous module can look like this for a typical HTML document. In HTML, we have the HTML tag or the HTML element, and then there's head and there is body, and there is a relation to that. So head is kind of a sub-element of HTML, as is body, and then another element, another relationship. Everything is connected in HTML, or if it's not connected in HTML, it will be connected once the browser parses the HTML and then sets up this, as I call it, DOM tree. And we see a few specific things here. We see HTML elements, we see text content, and we also see attributes. But that's HTML. When talking about the DOM, there are specific terms, and I'd like to discuss those terms with you now. The centerpiece, so to speak, of working with the DOM is a node. So basically, a node represents one thing, quote unquote, in that object tree, in that tree structure. So for instance, if we have, say, a P element, a P tag in the HTML, then there will be a P node in that tree structure. And then there are two more terms, and it's important that we know the difference. In HTML, we have attributes. So for instance, the style attribute of most HTML elements can be used to provide CSS. But there are other attributes as well, such as ID, for instance. So these are attributes in HTML, and there will be an API to read and also to set those attributes. But if we have a DOM node, there's more. We also have DOM properties. Imagine that we have an API, so we can program with DOM nodes. And of course, we can access those HTML attributes of those nodes or of those corresponding HTML elements. However, there are also properties, so that would then be JavaScript properties, since we're using JavaScript to interact with the DOM, and those properties are not necessarily attributes. For instance, you've previously seen the inner HTML property. There is no inner HTML attribute in HTML, but there is a property. So we can work with properties and have more options there than just with attributes alone. And now we are ready to dive into the DOM. The DOM API is huge, so we cannot cover everything, but I'll make sure that we talk about those things that you're most likely to use in your JavaScript-based applications. Let's start with looking at several ways to access a DOM element. So here's our tree structure again. We have HTML, we have head, we have body, and in the body part of the HTML document, we now have two paragraphs that will become important in a minute. You have already encountered the getElementById method. We've used that in the previous module. So if we have an element with an ID, we can access it via that ID. And as the name ID already suggests, there can only be one element like that. There are other methods, however, that return more than one element. Well, can return more than one element, or to be precise, more than one node. And one of those is getElementsByTagName. Notice the plural in the method name. So we get elements. Here, I just say, give me all the elements that have the HTML tag P. So in our example, there are two of those. And that's why getElementsByTagName of P will return a list of nodes, an array, And that list will contain 2 elements here. Another option is to call getElements by class name. So very often we are using CSS classes to kind of mark elements so that we can assign uniform styles to uniform elements. But in that case, we can also use that assign CSS class to get all of the elements that have one CSS class. And if an element has several CSS classes, the one that we provide in the getElements by class name call, that needs to be present, and it's not relevant whether there are any other classes or not. So that would work as well. And since we've already touched CSS, there's more, and nowadays that's probably the most commonly used way to access DOM elements from JavaScript, apart from maybe getElement by ID, and that's query selector. So query selector basically says, here is a CSS selector. On the slide, we have a very simple one, just P, which basically means element P. But we could have any supported CSS selector, supported by the browser. So whatever the browser supports can be used with query selector. So all of, say, CSS3 is possible. Query selector returns one element, and that's the first one that matches. So in our example, query selector of P returns the first P node in our tree structure, even though there is another paragraph as well. So if you're sure or certain that the CSS selector you're using only returns one node, you're good to go. Or if you specifically want the first node, make sure that your CSS selectors are that way. Otherwise, there might be surprises. If, however, you are expecting that you have more than one node that will match your selector, you can use query selector all. Query selector all works basically like query selector, so a CSS selector is expected as an argument. However, as the name suggests, query selector all of the matching nodes will be returned. So in our example, both the P nodes will be the value that we get when calling query selector all of P. And these are the most important methods to well actually access a DOM element. If you recall the demo from the previous module where we introduced getElement by ID, we could now change that and use query selector as a replacement. We just have to find a matching CSS selector for that element. So we could use something like footer and then div and then span, and the span has an ID of copyright year. But well, since we have an ID anyway here, in that case, and that ID has to be unique, we basically can just use the ID. And that's it. Now document.querySelector of hash copyright-year returns the node with the ID copyright year, so our span placeholder. And then once again, we write the current year into that element. We now know how to access any node in our DOM tree, in our DOM structure. CSS is so powerful, and that's why with query selector or the other DOM methods, we can basically go anywhere and then change that node. But what if we have a structure? So here's once again an example. What if we would like to move around? What if we would like to walk the tree? And that's called DOM navigation. We navigate the tree. And once again, I'll show you the most important APIs here. Let's start with the HTML node. And you see it has two subnodes, head and body. And subnode actually is not the correct term. They are child nodes. So we have a parent-children relationship. And everything is in order here from left to right, from top to bottom. So head is the first child of the HTML node, and appropriately, the property is called first child. And you may have already guessed it. If we are at the HTML node and would like to access the body node, we could use last child, because body is the last child of the HTML node. And if a node only has one child node, then first child and last child point at the same thing. Let's have a look at the children now. So head and body have the same parent node, the same parent element. Therefore, they are siblings. If we start at head and would like to access the body element, we can use the next sibling property. Also, if we are at the body node and would like to access the head node, we could use previous sibling. So when we are in the DOM tree, we can go downwards, so we can access children and grandchildren, etc. And we can also move to the left and to the right on the same level between siblings. But there's a bit more. We've seen first child and last child, but what do we do if a node has more than two children? Well, all of the children can be accessed with the child nodes property. That's always either empty or a list. Even if it's only one child, it will be a list then. So child nodes gives us that. So once again, we can go downwards within the tree, but we can also go upwards. Each node has a parent node, except for the root node, which is HTML here. So both head and body can use the parent node property to access the HTML node. So not only can we access any element in the tree, but once we are in the tree, we can walk around and therefore once again access anything there. Especially if you know the HTML structure of your markup really well, that can be really useful to then be able to access select elements or to search things in a predefined structure. We could use that DOM navigation in our demo code as well. So, for instance, we could use a selector such as footer div. Then we have accessed the div element, but what's next? What then? In the browser console, or in the developer tools to be exact, we see that the div element has three children: a text node, that's just text, then the span element, where we want to set the copyright year, and then another text node. So three children. That's the data we needed. So if I access child nodes, I get a list of three nodes with indexes 0 through 2, and we need the middle one. So this would access the div element, and then once again we would write the year into it. And of course we should add some error handling, make sure that we do have enough child nodes. We could also make the CSS selector a bit more precise, but this shows you that walking in the tree is also an option to access certain elements. We know how to access an element in the DOM tree. We can walk around the DOM tree. So let's now discuss how we can access specific content of elements in the tree and change them, because that's kind of a missing ingredient. So of course we start by accessing some DOM element. Doesn't matter how we do it, get element by ID, query selector, anything goes. And then if we would like to write something into that DOM element, so far the only thing we've seen is the inner HTML property, which sets the HTML content. So we can write both plain text and markup into that. That's not the fastest option, especially in an example like ours, where we just write plain text. Inner HTML expects HTML, so it parses what it gets. And we have to be careful whether that string we assign does not contain, say, JavaScript content, unless, of course, we specifically want it. But if we know it's just text, there are other options as well. Inner text is like inner HTML, but it just expects text. So if there are special characters like angle brackets, they are used as text. They are not used as markup elements. So that sets the text content. There's another option, and that's called aptly text content. And essentially it's the same thing, so there are some very, very subtle differences between those two. But also the text content property can be used to set the text within an element. So if EL here is, say, the span element for the copyright year, then we can set the text content with the text content and the inner text properties. There's one more. That's a property called node value, but that's not a property of an element like span. It's a property of a text node. If an element contains text, it has a child element, and that child element is a text node, and we can set the value of that text node. And that's why we have to use something like first child to get the text node dot node value here. Let's quickly go back to the DOM structure. So you see the blue nodes, DOM, Pluralsight, these are text nodes. For instance, the title. In the title tag of HTML, we set the title as a string by just putting text between the opening and the closing title tag. So the title node has a child node, that's a text node with a node value of DOM. Same for the text of the link on the right. So far about essentially changing text and markup, but what about HTML attributes? Indeed, we can change them as well. There is the setAttribute method. The setAttribute method expects the name of an attribute. So for instance, style or ID or anything else, and a value, and this then sets the HTML attribute. We could also read out an existing attribute by using the getAttribute method. And these are the major methods to change specific text and to some extent markup and attributes in the DOM. Back in our application, instead of setting the copyright year via inner HTML, we could use inner text or text content. So that would work really well here and would also be a bit more efficient than using inner HTML. What will not work is this approach. So child nodes of 1 gives us the span element with the copyright year. So we cannot do first child and then node value. Why? Because that span element does not have a first child yet. There is no text in it yet. If there was a placeholder like XXXX, then we would have a first child, then we could set the node value. But at the moment we don't have it yet. So we could either create a new text node, we'll see that shortly, or we just revert and use text content. Apart from changing the text content of an element, we could also change the layout by changing the CSS. And there are different options, and I'd like to show you which they are and what to use when, what the differences are. The first thing that probably comes to mind is setting the style attribute, because we've already encountered the setAttribute method. So if we have an element we call setAttribute and then set style to, say, color:orange, this would apply this inline style to that element because it sets or adds the style attribute, and therefore the text in that element would be in orange. Now previously we have discussed the differences between attributes and properties when it comes to DOM, and we can return to that topic now because each DOM element or DOM node has a style property, and this gives us an API to access specific styles. So for instance, we can access style.color and then set the color style property, so to speak. There are some subtle differences between setAttribute and using the style property. especially when we have styles with special characters like dashes. For instance, background dash color. Of course, there cannot be a property with a dash in it, so it will be background color with a capital C. But this also allows us to directly set styles. But of course, inline styles is not always a good way to make code maintainable. Using CSS classes could be a better option, and we could set the CSS classes as well with set attributes. So we could set the class property or the class attribute. But it's getting a little bit better with the class list property, because the class list property exposes an API to manage the list of classes assigned to that very element. Among other things, we have the add method to assign a class to an element, and we add it. So if there are other classes already applied to that element, they remain intact. Add just adds one extra class to the list of classes. You can also remove a class with the remove method. You have toggle to switch a class on and off, so to speak, and you can also replace the existing classes with a new class. And that's a little bit better than just going via the attribute, because then you have to parse the list of classes yourselves. The classes property does it for you. Let's try updating the CSS on the fly in our demo application. I once again start with document query selector, footer, and div. And notice that that div element has a couple of CSS classes. I've set them up in this application, and one of them is font-XX large. However, I think the font is maybe a little bit too large. So how about we access the class list and then remove font-XX large. That works well. However, in the next step, I would also like to add another class. I've prepared one, font-large, so that the font is a little bit large, but not extra large. Remove, however, returns void, so it's not chainable. Therefore, I can't change several things at once, removing and adding. Therefore, I need to do copy paste, call add, and then use font-large here. I remove one class and add another. Of course, I could do this in the markup as well, but if I want it to happen on the fly, maybe I have an increase or decrease font size functionality on the page. That would be one way to do it. Here's our application. Note the font size of the copyright line, and then I reload because we've saved our changes, and font size now is smaller, courtesy of JavaScript code. So far we have only changed content. Now let's get rid of some content. Let's remove DOM elements, and that's super easy. However, when you look at existing code bases, more often than not, you will see an approach that was the only option many years ago. And some developers are still so used to it that they can't get rid of it. And that's how it looks. First of all, once again, you get a DOM node, document get element by ID, document query selector, however you do it. And then, since each DOM node has a parent, except for the root node, and we have this kind of linked list, the parent node needs to be informed that one of the child nodes is gone or is to go. And therefore, in order to remove a node, you have to access the parent node and then tell the parent node, okay, please, I'd like to remove one of your child nodes. That's the one here. So you had a call that looked like this. Of course, it's not super intuitive. If you think about the DOM structure and the dependencies there, I wouldn't say it makes a lot of sense, but it's understandable. But of course, after a while, and thanks to popular JavaScript libraries like jQuery, the browser teams decided, okay, it's time for a more approachable API. And therefore, what they did is they added a couple of helper methods, and for removing DOM elements, it's just called remove. So each node has a remove method, and that remove method gets rid of the DOM node, removes the DOM node from the DOM tree. The browser renders, and the node is gone. In our demo application, let's go to the shopping cart. Yes, I know it's not really functional without a server backend, but I can show you how to remove nodes here on that page. So the shopping cart has a couple of items and also non-functional remove from this cart buttons. However, we could use JavaScript to actually get rid of some of those items. Here is the markup. The details are not that interesting. However, eventually we'll find that there is a div element with the idea of cart table. So it contains the table with the shopping cart items. We have the table indeed here, and then further down below a tbody element, and within that tbody element each tr table row is one item of the shopping cart. So how about this? Here at the bottom we just implement a helper function. So remove from cart, and then as an argument the index of the row, because where are the shopping cart items? We do a query selector all this time, so we are interested in a couple of elements, and we had cart table as the entry point, and then we had a table, and then we had tbody, and then we had rows within tbody. So this gives us all of the cart items. So how about we call this items? And then let's start counting from 0 as arrays do. So say we have 5 different items in the shopping cart. The index goes from 0 through 4. So if the IDX we provide is smaller than items.length, then we can happily remove it. So we access items of IDX because we now can be safe to assume it exists. Then we can just remove it. We don't know yet how to tie that code to that remove from cart buttons, but we can still use the browser console. So I make sure that I reload the page so we get the latest code, and then in the console I just call remove from cart, and then how about we just remove the second item here, so the index is 1. I just call remove from cart, and as you can see, that entry is gone. So we can now remove elements from our shopping cart, or since we're talking about the DOM, we can remove DOM nodes from the DOM tree. A common requirement when working with data is to provide CRUD functionality, CRUD, that stands for create, read, update, and delete. We covered reading, updating, and deleting so far. One thing is missing, creating. And once again, there are several options. Of course, if we would like to add something to the DOM tree, we have to start somewhere. So we have to access an element and then start from that element. That element serves as a placeholder. And then we could just be lazy and, well, assign some markup. That is okay. As I've mentioned before, it's not super efficient, and you have to trust that markup, because if it's user supplied, maybe there's JavaScript in there, that's certainly not what you want. But there are other options as well. Remember that we have that tree structure. So if we would like to add something to that tree structure, we have to think in that structure. We have to know about parent node, child node, dependencies or relationships. And then we have to add elements using that paradigm. And I'll show you how that's done. There are a few API steps. It looks cumbersome at first, but especially when automatically accepting structured data and putting that onto an HTML page, that approach works really, really well and is then also easy to understand. So first of all, when we'd like to add something to a page, say a paragraph with some text, we have to create that element. And the DOM method for that is document.createElement. And the argument expected is the name of the HTML tag. So it's just P. It's not angle brackets P, it's P. And that creates a new element in memory, so to speak. Nothing gets rendered. That's good for all elements within angle brackets, but you've already learned that there are also text nodes for text content. Well, these can also be created using an API. And that method is then called document.createTextNode. Document.createTextNode creates, as the name suggests, a new text node. And of course, we could use the new _p element we've created and set its text content, but I like to show you both ways. Because now we have two nodes. We have the p node, representing a paragraph element, and we have a text node. And what's their relationship? The text node needs to be a child of the paragraph. And for that, there's a method called appendChild. So appendChild takes another node and makes it an extra child, and if there's none, the first and so far only child of an existing node. So we say new _p, our paragraph node, dot appendChild gets a new child node, and that new child node is the text node we've just created. So now in memory, we have a paragraph with some text in it, essentially. And then what's next? Well, we would like that paragraph to be rendered, so we have to add it to the page somehow. And since we already have our placeholder, why not just use the placeholder and then call appendChild for the placeholder. And if you have a more complex structure than that, you of course have more appendChild calls. There are also some helper methods similar to remove. For instance, after, which adds an element after another element or before. But most of the time, appendChild is what you'll be using. The ability to add new DOM elements to our HTML pages gives us great opportunities for our application. For instance, we could dynamically fill the shopping cart or fill the table of events. However, since there's quite some markup involved, it also includes quite a number of API calls. So let's start with something simpler here. In our footer, we have the copyright notice, and we also have Globoticket, the brand name. This could be turned into a link, and we do that by showcasing a few of the things we've already learned. We first remove the Globoticket text node, and then we add a link in its place. And I'm happy to do that here in our code. So maybe here in between. And here's what we could do. First of all, let's access that Globoticket text node. Remember that the div element here has 3 child nodes: the copyright character, then the span element, and then Globoticket with a blank. Let's remove the letter. So once again, we do query selector as method of the document object. We access footer div, then we access the last child, and then we remove it. That's the first step. And then we can add a new element. So first of all, I would like to create a text node that's just a space character, because there's a space character in front of Globoticket. And that should not be part of the link. So how about we create blank as document create text node with just space character. And since I'm using the footer div element a couple of times, I'll put this in a variable now. So how about we just call it placeholder, document query selector, and then footer div, and we can use that actually everywhere here. So placeholder it is, and further down below placeholder it is. And now we can add that new text node as a new child to our placeholder. So placeholder append child blank. And now let's create the new link. So I start with document, create element. And since it's a link, it's A. I set the href attribute for the link target. So a.set attribute href, and I set it to, let's just say, index.html, but it could be anything else. And then I either create a new text node and append it, or I set the text content property. Let's just create a new text node so that you see this in action once again. So I call the element a href, or a text would even be better. And then document, create text node, Globo ticket it is. And then we put everything together. So a append child, a text. So we append this text node as a child to our new link. And then I go to the placeholder. The placeholder receives a new child, and that's the link we have just created. Back in the browser, refresh the page, have a look at the footer at the bottom. There we go. And now we do have a link in the footer. And if we have a look in the browser DevTools, you will certainly see that now the div element has a couple of child nodes. So we have the copyright character, we have the placeholder with the year, we have the blank. The blank isn't shown here specifically as a text node because there is just a blank in it, where in the parsing it is not considered specifically a text node, because then all of the indentations would have to be shown as text nodes here. But technically, yes, there is a text node, and we can actually prove that by doing document query selector, and then we just go to footer and div, and then we have a look at the child nodes, and you see indeed the length of the child nodes is 4. So yes, we have 4 child nodes. So the display here might be a bit confusing. It's the first child node is the copyright character, the second one the span element, the third one that blank we specifically created, and the fourth one is our new link. So we can now add arbitrary DOM elements to our pages. We can now completely change the DOM. We can create elements, we can read elements, we can update elements, and we can delete elements, so full CRUD. But so far, this happened ad hoc. But we would like to have some user interaction and would like users to trigger those things. And that's what we need event handling for. That's up next.